All right, so let's look at trigonometry. All right, trigonometry summarized. The first thing is trigonometry is all about right angle triangles. What does that mean? It means that the triangle has to be 90 degrees in order to do trigonometry with right angle triangles. You do have other concepts around it, but for now we're doing right angle triangle trigonometry, which means that this angle over here is 90 degrees. The first thing we need to identify is if my angle is positioned over here, then this side will become my opposite side. This side would be right next to it, so we just use the word ADJ for adjacent. And whenever we find the longest side, we call that side the hypotenuse. And likewise, I could have the triangle go the other way. I could have a triangle go the other way like that. And let's say the angle was at the top this time. Then this side becomes opposite. The longest side is my hypotenuse, and the side that's right next to the angle is known as my adjacent side. Now, the reason I need to remember all of this is because when I decide to choose a specific trigonometric function, I have three choices. I have sine, which is given as opposite over hypotenuse as a ratio. So sine would take the opposite length and divide it by the hypotenuse. So for example, if this was 4 and this was 5, then this would be 4 over 5. And it doesn't have the adjacent, so we don't really need the adjacent for sine as well. Okay. And then we got cos, which is given as a standardized ratio ADJ adjacent over hypotenuse. So that would be this length over this length, or this length over this length as well. And so let's say this is equal to 3 and this is equal to 5, then this would be equal to 3 over 5. And let's say this was equal to 6 and this was equal to 10, then that would, particularly for this one, cos of theta will equal 6 over 10. But notice that the 6 over 10 is coming from the adjacent and hypotenuse. So don't get confused. Don't use the opposite for cos. Opposite goes to sine. And it also goes to tan. But tan doesn't have the hypotenuse as well. Let's go to the next one. Tan. Right, so tan is going to be given by opposite over adjacent. We don't need the hypotenuse over here. So wherever you're at, this is going to be opposite, this is going to be adjacent, and that's what we would put in there. All right. Hypothetically, whatever value it is, it's a ratio of numbers. So number at the top, number at the bottom. Opposite, these are all lengths. All of these are lengths of sides of a triangle. All of those are angles inside the triangle, either on this side of the triangle or on the side of the triangle. All right. Now to remember this, what we've done is we've taken the S, the O, and the H, and we've produced what is known as SO. Then we've taken the C, the A, the H, and we've produced what is known as Ka. Then we've taken T, O, and A, and we produce what is known as Tua. And so we try and remember this every single time we do right angle triangle trigonometry. So sine opposite over hypotenuse, Ka, cos adjacent over hypotenuse, and Tua, tan opposite over adjacent. And so with that, we can test this on actual values. So let's look at an example. Let's suppose I have a right angle triangle. And because you are given three possible unknowns, so you have your opposite, your adjacent, and your angle in each case, a side, angle, a side, and an angle. In any given triangle, you can be given two sides and an angle, and that's all you need. Or two sides to find an angle, or an angle and a side to find another side. So let's suppose this angle over here is given as 30 degrees, and this side's length over here is given as 4 meters. And I'm asked to find the hypotenuse length. They're not asking me for the adjacent. They've given me the opposite, and they want me to find the hypotenuse. So the trick here is to choose the correct trigonometric formula to use. So I've got O, right? Let's write it down. I want to find H. It's in there. So which one has O in it? Oh, sine has it. Right. So that's going to be so. So for this particular question over here, what I would do is I would say sine the angle is equal to opposite over hypotenuse, which is sine the angle equals 4 over the hypotenuse. Now I want to find the hypotenuse. So what I'm going to do here now is I am going to solve and make that the subject of the formula. All right, I need to get it alone on one side with everything else on the other side. Now, generally, when the unknown is in the denominator, right, when the unknown is in the denominator, then what we have to do is we have to swap over, right? We swap over the denominator and sign, all right? And so that will come to hypotenuse equals 4 divided by sine 30 degrees. And so we need to have a calculator, obviously. So go to a calculator, press the fraction button first, then put 4 at the top and put sine 30 at the bottom. So fraction button, 4 at the top, sine 30 at the bottom. Comes to 8. What have I found? I've just found that this length of the hypotenuse is 8 meters. I have not found the adjacent side. They did not ask me for it, so I do not need to worry about it. They've asked me for the hypotenuse length of the year, and they've given me the opposite, so I only need to use sine. Okay, let's have a look at an example where we're using cos. So let's suppose we're given another right angle triangle in a different angle. This angle, let's say, is 60 degrees, and they tell me that this length over here is 10 meters. And they want me to find the hypotenuse again, but this time they call the hypotenuse x. Let's remember that that is the hypotenuse. This is the adjacent. So which one am I going to use? I'm going to use adjacent hypotenuse. So I'm going to use cos. So I know I'm going to write cos of the angle equals to adjacent over hypotenuse, because that's the standard formula. And adjacent is given as 10, hypotenuse is given as some x value, and the unknown is in my denominator. So when the unknown is in my denominator, all I need to do is just swap these two around. And it'll become x equals 10 divided by cos 60. Grab a calculator, press the fraction button, put 10 at the top, and put cos 60 at the bottom, and you will get the following answer. So 10 over cos 60 will come to 20. And so what have we calculated over here? 20 meters. That is the length of that hypotenuse. Now you can get given any side at any point in time, and you can keep using the same thing. Let's have a look at 10. Let's suppose I have the angle 30 degrees again, and I'm given the opposite side to be 20 meters and the adjacent side over here to be 40 meters. All right, well, we want to find one of them. So let's suppose I don't know this length of here. Let's label it. That is my opposite side. So it's going to be either sine or tan. This is my adjacent side. So it's going to be either cos or tan. It looks like I've got O and A. Wow. Which is going to be 2. All right, which means I use tan. So let's write down tan of the angle equals opposite over adjacent, and that's going to be 20 over x equals tan of 30 degrees. Because the unknown's at the bottom, I can swap both sides and I get x equals to 20 over tan 30 degrees. Put that on a calculator. Now remember, the unknown can be at the top, because if the unknown was 20 and 20 was x, then the unknown would end up at the top, and that would be we multiply. But in this case, we're just going to swap x and tan 30. Fraction button, 20 at the top, tan 30 at the bottom, and it shoots out 34.6. 34.6 meters will be this length over here. All right, and here we use tan. So whenever we do these questions, we need to write down the saw car to us. We just write saw whenever we start car and tour, so we remember what we're dealing with. Let's see if we do some random triangles with random angles in random places with some random sides, finding unknowns. Okay, so let's have a look at this now. Over here, I've got 40 degrees, and I want to find this side, but they're giving me this length to be 100 meters. Over here, I'm told that this is 30 degrees. I want to find this side, and they're telling me this is 50 centimeters. Here, I'm given this as 25 degrees. I know that this side is 17 meters, and they want me to find x on this side. In each case, we have to find x. So we've got to decide which one to use. The first thing is, because my angle is over here, this first triangle would mean that that side is opposite. There's my 90, and I know this is my hypotenuse. So I'm not really needing the cos function because I don't have the adjacent. And definitely not tan because it also needs the adjacent. I have opposite and hypotenuse. Even if I don't know the opposite, that's what I'm looking for. So I'm going to use opposite of hypotenuse, which is going to be sine. So I'm going to go sine 40 equals opposite over hypotenuse, x over 100. Now you can see that the unknown is at the top. When the unknown is at the top, all we have to do is just simply multiply the left-hand side by 100. And so we end up with the following. We end up with sine 40 equals to, well, 100 times sine 40 equals to x. And we put that on a calculator, and we're done. 100 multiplied by sine 40. Make sure you close the bracket if you need to at the end of your calculator for 40. All right, 100 sine 40 or times sine 40 comes to 64.23. 64.23, and it's meters. So that's going to be this length over here. The opposite. What have we found? We found the opposite. How did we write this? Remember, sine is equal to opposite over hypotenuse. So I put opposite at the top, and I put the hypotenuse at the bottom, like that. Okay. Now, next, car. For the next one, well, I don't know if it's going to be a car. Is it? Maybe. All right. Let's label it. If I'm standing over here at 30 degrees, then this side is my opposite. Right next to it will be my adjacent. And opposite the 90 degrees, the longest side is your hypotenuse. So for this particular question, I know my adjacent is x, even if it's unknown. And I know my hypotenuse, it's 50, but I'm not given the opposite. So I'm given AH. So I'm going to use cos, and I start by writing cos of the angle 30 degrees equals x over 50. Now I'm going to multiply the left-hand side by 50. 50 times cos 30 degrees equals to x. Put it on a calculator, and you can see, because the unknown's at the top, we're not swapping. Remember before, we swapped. All right, because the unknown was at the bottom, we swapped it around. X ended up there, tan ended up there, but now we're not swapping. Okay, we're multiplying the denominator 50 by cos 30. So we just put 50 cos 30, and that comes to 43.3. 43.3. It's not a degrees, it's a length. So centimeters, and that's going to be x. It's a side length. The next one, this is my opposite side. This is right next to it, adjacent side. And this is my hypotenuse. I don't need my hypotenuse. So I'm going to use TOR, opposite and adjacent. So we're going to write tan 25 degrees equals 17 over x, opposite over hypotenuse. Notice it's the first letter over the second letter, first letter over the second letter, first letter over the second letter. So this is going to be tan equals opposite over adjacent. If you know what the opposite is, it's 17, adjacent is x. Again, we have the unknown at the bottom. When the unknown is at the bottom, we just swap it. Put whatever's on the other side to get it along. And here we end up dividing by 10. Putting that on a calculator, 17 over 1025 will come to 36.5. 36.5. Now, if you use one decimal place, two decimal places, you can round it depending on what's required. And this is meters. 36.5. 36.5 meters over here. All right, so 36.5 meters, 43.3 centimeters, 64.23 meters. Okay. And now we have trigonometry in a nutshell, calculating missing sides. The next thing is we need to find angles using trigonometry now. What does this mean? This means that if I have a triangle and I have two known sides, and let's write down our SOHCAHTOA. We still use this, but I don't know the angle now. And I know this is 14 meters and I'm told that this is 20 meters. Give me the angle. So if I'm standing over here, this is my opposite side. And that's the longest side. So that's going to be my hypotenuse. So I can see opposite hypotenuse would be sine. So I go sine of my angle, which I don't know, is equal to 14 over 20. And so now I'm going to move sine over. And so theta is going to be shift sine on my calculator. Press shift first, then sine. Then put the ratio of side lengths in there. And so theta will equal shift sine. So grab your calculator, press shift sine, fraction button, put 14 at the top, put 20 at the bottom, close the bracket. They'll come to 44.4. 44.4 degrees for angle theta. Okay, 44.4 degrees would be angle theta, and that would be that there, the angle from there to there. All right, in this particular question, we were not given the adjacent side, so we did not use the adjacent formulae from that. Let's repeat this process now, but let's change it up a bit. We still don't know the angle. Let's suppose I'm given 25 millimeters and the unknown x over here. Let's label the sides. This is adjacent. This is hypotenuse. So I got to use cos because it's C, sorry, ca. So ca means cos equals adjacent over hypotenuse. What is my adjacent? 25. What is my hypotenuse? X. In this equation, the unknown's at the bottom. So what do you notice about this? I can't do this question. I don't have enough information. I don't have x and I don't have the angle. All right, so I need to be given another side. Let's suppose I'm given the other side over here to be, let's say, 30 millimeters. And if I am given that other side, that's going to end up as my opposite now, which means I will have my opposite and I will have my adjacent. So for this over here now, I've got my opposite and I've got my adjacent. I can use that to find theta. using tan. So if I go tan theta, it's going to equal opposite over adjacent. And so tan theta is going to equal 30 over 25. And so theta is going to equal shift tan 30 over 25. We then put that on a calculator. We put it on a calculator and we say shift tan 30 divided by 25, and it comes to 50.2. 50.2 degrees. Don't forget that means press shift, then press the fraction button, then press equals after that. And that's how you would go there. Right. So in this case, I've now found my angle to be 50.2 degrees. I could not find it earlier because I did not have the x value. But now I have the opposite value, and so I can even find the x value as well using Pythagoras theorem. Pythagoras theorem would basically state that x squared is equal to 30 squared plus 25 squared, and it'll become 900 minus 25 squared, which is 625. And I'm now going to say 900 plus 625 using Pythagoras theorem quickly, but we're not really focusing too much on that just yet. But I'm just going to quickly work this out. Square rooting both sides. The square root of 1525 is 39.05. And so this is going to equal 39.05 millimeters for that length. This is 30 millimeters and this is 25 millimeters. Sokatua. All right. Let's change it up again. We're finding missing angles. What happens if I'm given another two sides? What you've learned from this is that you have to know both sides. You can't be given one unknown side. You have to have two known sides to find the angle. All right, let's say the angle's at the top. This side's 127 kilometers, and this over here is given as 300 kilometers. Two known sides, find the angle. First, we label it. Opposite, longest side, hypotenuse. Choose which one. Looks like sine. Sine theta equals opposite over hypotenuse. I got that, I want to find that. So sine theta equals 127 over 300. Theta is going to equal sine to the negative 1, which means shift sine. And then theta is going to equal, from that, shift sine 127 over 300. So shift sine, fraction button, 127 over 300. That'll come to 25.045. Okay, so let's say 0.5 degrees. And now I found the angle using sine. If I was given these two sides, I would use tan. If I was given those two sides, I would use cos. And use shift cos at the end as well for that. Right. So let's say the next question now says we have to solve the right angle triangle. Okay. I'm given a triangle and I want you to find all the missing sides and find all the missing angles as well. Okay. So now from this, I'm given that this is 25 degrees. This is a block, which means 90. This is 107 meters. This question asks me to find the length of x, this angle theta, and y. We want to solve the triangle. That means we want to find everything. We're going to find theta. Think about Pythagoras theorem. We also want to find the angle. So x, y, and theta. So we can start from any one of them. Particularly, what we should realize is that the angle theta can be found first, because theta plus 25 plus 90 degrees is equal to 180 degrees. So theta can be calculated by angles in a triangle. So this is going to be 115 degrees equals 180. And if I minus that, that will become 55 degrees. Right, so that'll be 55 degrees on this side. Just double check that. What is 55 plus 25? That's 80. All right, I can't count. It's going to be 65 degrees. That's 65 degrees. 65 plus 25 is 90. Plus 90 is 180. Right? Okay, next part. I've now found theta. Done. Let's have a look at finding one of the others. Now, if this is 25 degrees, I could start from 65 and get y or x. I could use 25 and get y and x. But if I got 65 incorrect, I could rather rely on 25. Let's start by labeling the sides. I've got hypotenuse. And if I'm positioned over here, this is going to be 25 degrees. And this is going to be my adjacent. And this will be my opposite. Let's do two calculations to get each of those. All right, calculation number one. The first one I'm going to try and find is x. It's opposite hypotenuse. So let's go. So, ka, to. Opposite hypotenuse, so. So sine of 25 degrees is going to equal x over 107. And now I'm going to multiply this on the other side. It's going to become 107 times sine 25 degrees is equal to x. When the unknown is at the top, we simply just multiply it. So take 107 and multiply it by sine 25 on the calculator. That'll come to 45.22. X will equal 45.22. Okay. All right. Looking at the next one, adjacent and hypotenuse, I could use cos. Now I won't use tan because I've already found x. X is done. But I need cos to find y because it's in the adjacent. So cos of 25, and I'm still sticking with the 25, is equal to adjacent of hypotenuse, which is y over 107. We now multiply this on the other side. So 107 cos 25 will come to y, and that will get me my answer for y. Y is equal to, or it's equal to y, which means the same thing. So 107 multiplied by cos 25 equals 96.97. 96.97 will be y. This is in meters, and this is also in meters. And I've now solved the triangle. I found x, I found y, and I found the missing angle for that. All right.